How's going, everybody? Welcome and welcome back to another reading of the Rust Async book, or Async Rust book. Where were we last time? I think last time we were in painting. Async Rust just has been such a tremendously mentally consuming topic for me that it just feels very tedious. I don't know. It is pretty goddamn hard, but you know, I feel like the thing about everything is that you can't just do simple stuff, right? If all you do is simple stuff, humanity is not gonna move forward, right? There's always going to be people, not always going to be, but there should be people willing to try out hard things. And even though this is not something that I personally think would be very particularly helpful career-wise, because I don't think fucking anyone cares about Rust. Most people are still using JavaScript, very unfortunately. It's also very unfortunate that half of the world still runs on fucking PHP. But it's something that I feel the responsibility to learn. It's something that I ought to do. So today, let's continue our journey by reading pinning. Pinning. To pull features, they must be pinned using a specific type pin T. If you read the explanation of the future traits in the previous section, executing futures and tasks, you'll recognize ping from self-ping mute self in the future poll method, in the future poll method's definition. But what does it mean? Yeah, that's a very good question. And why do we need it? Why pinning? Ping works in tandem. Ping works in tandem with the unpinned marker. Pinning makes it possible to guarantee that an object implementing unpin makes it possible to guarantee that an object implementing unpin won't never be moved. Okay? To understand why this is necessary, we need to remember how async await works. Considering the following code. Okay, we have future 1, future 2, and async move. We move and then await. I don't understand it. To understand the hood, under the hood, this creates an anonymous type. This creates an anonymous type that implements future, providing a pull method that looks something like this. So we have, okay, creates this thing. Where's the state coming from? Okay. So just keep track of both. Wait, how? Interesting. I don't get it. What about waiting for both though? There's definitely a chance that we're going to wait for both, right? Announcement. Okay. Anyway, future for async future. Okay, well, future for async future. What is this? This is the element we generate code. We have this, and it's gonna match states. Okay. Oh, so basically, it's just a scheduling mechanism. Yeah, it's just a scheduling mechanism. When poll is first called, it will poll field 1. If field 1 can't complete, async future poll will return. Future calls to poll will pick up where the previous one left off. This process continues until the future is able to successfully complete. However, what happens if we have an async block that uses references? For example, this, whatever this shit is. Use this reference. Okay, we have this. It's is that an array? Reading to buff. Okay, so now we have a buffer. Oh, and this one is a asynchronous function, if I'm understanding correctly. And then we're gonna await it, and it's gonna print. What is this compile down to? Compile down to this. What is fucking A here? Have a buffer, yeah. Async future, yes. What lifetime? What the fuck even is a lifetime? I'm so cooked. I don't understand shit. Bro's getting bamboozled. Am I getting bamboozled by fucking Rust people? Or am I just too stupid to understand anything? Is this some like high intellectual thing that I just can't understand because I'm fucking stupid? Here the read into buff future holds a reference into the other fields of our structure, X. However, sorry. Here, the read into buff future holds a reference into other fields of our structure, X. However, if async future is moved, the location of X will move as well, invalidating the pointer stored in read into buff fields.buff. Pinning futures to a particular spot in memory prevents this problem, making it safer to create references to values inside an async block. I'm actually getting a whole lot more confused, shall I say, about Rust, because I think one problem with Rust is like the async Rust is really hard, and because we have all of those crazy lifetime thing, it seems rather hard to optimize for it. And if we are doing like atomic counting or something, it is actually going to be really slow, and it kind of defeats the whole purpose. But I don't know. I just really don't know. Making it safe to create references to values inside an async block. Pinning in detail. Let's try to understand pinning by using a slightly simpler example. The problem we encounter above is a problem that ultimately boils down to how we handle references in self-referential types in Rust. The problem we encountered above is a problem that ultimately boils down to how we handle references in self-referential types in Rust. For now, our example will look like this. We have a direct debug, we have a test, it has a string and another constant pointer to a string. What is that? It has a new method. It's gonna create a well, fuck. I'm so cooked. I'm so fucking cooked. I feel like I just have serious skill issues working on large projects. So like, I don't know. I don't know. I don't really know. I think that the problem about like a lot of things is that I don't know. Anyway, we have a string. It's gonna. Yeah, this b is going to be a null pointer. So yeah, I guess it's probably just a. Wait, you can do null pointer in fucking Rust? That's stupid. Why the fuck should you allow that? That's so silly. That is downright goofy. What the fuck? That's a very good question, actually. Let's try to understand pinning by using a slightly simpler example. We have this and a null pointer in it. And it is going to what? Self-ref is going to be a string. What? B is going to be a self-ref. Okay. So basically, when calling init, it's just going to set B to A, basically, if I'm understanding this correctly. A is just returns A. Wait, how? Okay, what? Why do we have so many fucking strings in Rust? This is so silly. I don't know. I feel like the more I work with Rust, the more frustrating I becomes. The more frustrated I becomes. Like, it started all nice and kosher, right? The fucking type system and all those things. But the Rust is like surprisingly not ergonomic, if that makes sense. But I feel like Rust is in a very interesting position where it has a surprisingly solid ecosystem. That is just like solid. I don't know what else to say about it. Like, sure, you get like a lot more like legacy and just like really good high performance libraries with C and C++. But with Rust you get like almost the same thing, but it's more modern, if that makes sense. Because like with languages like Zig, you don't really get to use the Rust SDK for let me just check. Use Rust in Zig. Rust matrix SDK Zig. C. How do you actually? I just want to know if there's any other decent SDKs out there. There actually is fucking none. The Rust SDK is also in fucking beta. Ah, man, this sucks. This really sucks. Oh wait, Ruma is a stable SDK. And what's the difference between Ruma and the I think the Rust SDK thing includes Ruma, right? I don't get it. What is Rust? What is Ruma? Documentation, introduction here. Review, client events. It just has really, really bad documentations, unfortunately. God damn it. Anyway, let's just continue with the async Rust. I feel like that's something I just kind of have to do. So when B is caught, assert B it cannot be null, right? And then we're gonna go with a unsafe thing. That can be fun. I don't know. Test provides a method to get a reference to the value of the fields A and B. Since B is a reference to A, we store it as a pointer since we borrow rules with. Since B is a reference to A, we store it as a pointer since the borrowing rules of Rust doesn't allow us to define this lifetime. We now have what we call self-referential struct. Okay, so it's referring to itself. Our example works fine if we don't move any of our data structure around, as you can observe by running this example. Okay. Here's what we expect. Let's see what happens if we swap test 1 and 2 and thereby move the data. Oh wait. Oh yeah. Wait. Oh, you get to move the data by calling init, right? Is it? It's still. Wait. Yeah, this works. How do we swap the? Okay, yeah, well, mem swap. Naively, we could think that what we would get in debug print is just something like this. But instead we got, what is std mem swap? What even is that anyway? You pass a reference and they swap the memory. Is that how it works? Oh, it's not swapping both. Wait, it is swapping both. I'm confused. Why would we expect this? Because I think it's because we call the first one before. Okay, interesting. The pointer to test2b still points to the old location, which is inside test1 now. Wait, wouldn't it change the value though? Cause when you swap the data, this one is also gonna get swapped, right? We swapped 1 and 2, and we print 2. So this should actually just be 1, right? We are... Oh yeah, this should be like this, but I don't know why we got this. The pointer to test2b still points to the old location, which is inside test1 now. The structure is not self-referential anymore. It holds a pointer to a field in a different object. That means we can't rely on the lifetime of test B to be tied to the lifetime of test 2 anymore yet. If you're still not convinced, you should at least this should at least convince you. I guess it's just I don't understand how swap works. Like if you swap two oh, is it like copy? Like instead of just like changing the reference of test 1 and test 2, you actually like kind of copy the memory of test 2 to the memory location of test 1, and then you copy test 1 to test 2. But that still won't be correct though, because like this doesn't make any sense to me. This is really fucking confusing. This is like actually just confusing. Am I getting bamboozled? Why this behavior doesn't make any sense? Cause like if you swap the memory location, like you either copy the data, in which case the actual content is changed, right? Wait, hold on. Let me think about this. Yeah, I can say. Wait, which one are we printing out? We're printing out test 2, right? So like if we have 2 memory blocks, I can see how if you copy the memory of. Yeah, I actually thought the opposite would be true, right? Cause like if it's about like copying memory, wait, should it? Like A should always work, cause like A is like entirely copied over. B is also entirely copied over, and now it points to the location of 1, right? Since 1 and 2 are swapped. Oh no, wait. No, wait. I mean, I'm confused. Let's just see the following example if this will convince me. Again, we create 2 objects. We changed we swap 1 and 2, and then we changed 1 before and after swap. So before the swap, we have A in this address, B in this address, right? Which is a pointer, points to this address. Oh yeah, test 2 is like, yeah, it's self-referential. Yeah, I can kind of see what is going on here, but I guess I'm just too stupid. I'm actually just a fucking retard. I don't get it. Probably shouldn't masturbate that much. Yeah. Actual fucking brain rot. Dude, our generation is doomed. So fucking doomed. We're so cooked. We're so cooked. It's easy to get this to show undefined behavior. Yeah, I mean, copying pointer is always going to result in like very wacky behavior, right? Because you're not, the pointer is not pointing to a relative location. It's pointing to a kind of a absolute address. I know why, like, if you can move things around, it's definitely going to result in like wacky behavior. I can see that, but I still don't. I guess I just don't understand how swap works. Basically points to the old memory, right? But wouldn't this just be the same value as this, though? No, it won't be. Oh yeah. I guess I'm just stupid. I mean, this diagram makes sense. I guess I'm just too stupid to understand why this should be the result of what we've got. Cause like when we swap A and B, right? This is the original. This is the original A, right? This is the original A, and we swapped it, and now it's like this. Oh, sorry. It's like now we're here, and this is pointing to here. Oh. Okay, yeah. That actually makes a lot of sense now. Yeah, I'm actually just a fucking retard. Okay, yeah, I'm a gigantic fucking retard. Okay, it makes a lot of sense actually. I really don't know how that was confusing for such a long fucking period of time, but I don't know. I guess I just have like teeny tiny brain. Pinning in practice. Let's see how pinning and the pin type can help us solve this problem. The pin type warps pointer types, guaranteeing that the values behind the pointer won't be moved if it is not implementing on pin. For example, pin mute T, pin box T all guarantee that T won't be moved if T. This one, it doesn't mean fucking macro. It just means fucking not. This is so silly. I hate this notation. Most types won't have a problem being moved. This type implements a trait called onPin. Pointers to onPin types can be freely placed into or taken out of pin. For example, U8 is onPin, so pin mutes UK behavior just like normal. Okay. However, types that can't be moved after they are pinned have a marker called onPin, not onPin. Features created by Async await is an example of this. Okay. I guess I need to learn more about onPin. Most types won't have a problem with being moved. Oh yeah, so something like this, right? This types implement a trait called onPin. pointers to unpinned types can be freely placed into or taken out of pin. Okay, I think I know what is going on here. Which can be totally wrong. I don't exactly have a great track record of being, sensible. But I think I know something. I think I roughly know what is going on here. Alright, pin into the stack. Go back to our example. We can solve our problem by using pin. Let's take a look at what our example would look like if we required a pin pointer instead. Marker. What is this? Phantom pin. What is phantom pin? This marker. Wait, hold on. I'm retarded. What is that? Types can't be moved after they're pinned. Okay, we add a new marker, and we just initialize. What? Just by having a marker here, you're just gonna make it not on pin. And the rest are the same, right? Yeah, it looks like it. The rest are the same. Pinning an object to our stack will always be unsafe. Always be unsafe if our type implements unpin. If our type implements on pin, okay. Kind of see where that's coming from. You can use a crate like a pin util to avoid writing our own unsafe code when pinning on the stack. Below, we pin the objects test1 to the stack. Wait, is the new unchecked? Where's new unchecked coming from? Where the oh, okay. Oh yeah, we pin it. Testing it, test1 as mute. Also, we kind of created a pointer. And now we can't write things in a very OP fashion. That's so weird. The syntax is so confusing. I don't know. I just hate the way that Rust works. I hate the fucking syntax is all over the fucking place. Test 2 new unsafe uncheck. Test 2 okay. Test init. Test 2 as mute. We have yeah, it's literally the same thing. Now if we try to move our data, we'll get a compiler error. Okay, it doesn't stop the fucking problem. It doesn't solve the problem. It just stops. It just yells at you. That's the only difference apparently. It's important to note that stack pinning will always rely on guarantees you give when writing unsafe. Well, we know that the pointy of I was thinking about it. I need to think about it. It's a very good question. really don't fucking understand shit. It's important to know that stack painting will always rely on guarantees you give when writing on save. While we know that plenty of this reference A mute T is pinned for the lifetime of A, we can't know if the data points to this shit is a move after A ends. If it does, it will violate the pin contract. A mistake that is easy to make is forgetting to shadow the original variable, since you could drop the pin. Forget to shadow the original variable, since you could drop the pin and move the data after this, like shown below, which violates the pin contract. Oh, it's just kind of say, okay, we painted, but I fucked it up. Wait, what? Oh, you dropped the pin. Is that gonna free the variable or something? It's just another whoopsie daisy. Like, I don't understand why people are saying Rust is such a fucking safe language. It provides a lot of safety features, right? But this is a very clear example of why you can still shoot your Rust still gives you a foot gun. Like, programming is just fucking hard. Like, sorry to bring that to you, but like, programming is just fundamentally hard. And like, this is like, no language is safe. You either get like no shit, dog shit, like fucking JavaScript, in which you can't do anything, or you get fucking Rust, which tells everything about what you're supposed to do. I don't know. Pinning to the hip. Pinning an unpin type to the hip gives our data a stable address, so we know what the data we point to. So we know that the data we point to can't move after it's pinned. In contrast to stack pinning, we know that the data will be pinned for the lifetime of the object. Yup. Wait, what is box? Is box Rust box versus ref? Are they the same thing? First of all items you listed are really different things. Okay, even if they're all related to pointers. Box is a library-defined smart pointer type. Ref is a syntax. Okay, it's a syntax for pattern matching. Okay. Ref is a reference operator. Double as a single in reference time. This is the reference. Okay. What the fuck is a box then? Is box just like a stack pointer? Boxes, in fact, this is true for almost all other smart pointers, like RC, can also be borrowed. Okay, it's just a fucking interestingly. So basically this gives you a stable memory address. It's just a new. It's just a fancy way to use new. I mean, it's interesting. Okay, we've got this. It's gonna create an object. Right, then we got our boxed. We're gonna box and ping. Okay, that's a syntax trigger, if I understand correctly. Self pointer is a string. It's gonna borrow this shit and it's on. Okay. Oh, it just creates everything here, and we don't have the init. down there. Some functions require the futures they work with to be unping. Okay? To see a future or a string that isn't unping with a function that requires unping type, you will first have to ping the value using this or this macro, okay? To create this, okay, and this can both be used as futures and both implement unping. This is a very confusing statement that I don't get it. Some functions require the futures they work with to be unping. To use a future or a string that isn't unping with a function that requires unping types, you will first have to ping the value using either this or this. And this can both be used as futures, both implement something. Oh, so basically it's saying you can just like create a new reference and then instead of dealing with the complexity of like something that you just can't fucking ping, you can just create this no matter what. Creates like a whopper around it. Is that what it's about? I'm fucking retarded. I don't get it. Okay, we have this. We have execute unpin future. We got a future. Execute unpin future. Pinning with box. Yeah, we can execute unpin future. Oh, so we cannot just like execute the this one because it doesn't implement unpin trait. Oh, it's the plus sign means like and when for its type. Rust just has a very, very complicated type system, which I don't know. I'm too stupid for that shit. Summary: if T unping, which is the default, then this is entirely equivalent to this. Okay. In other words, unping means it's okay for this type to be moved even when it's pinned. So ping will have no effect on such a type. Get this to a pin requires a nonce. Yeah, immediate reference to a pin T. So most standard libraries implement unping. The same goes for most normal types you encounter in Rust. A future generated by async awaits is an exception to this rule. Kind of get where they're coming from. That's interesting. You can either ping data to the stack or to the heap. Ping a unping object requires unsafe. On stack requires unsafe. Ping this on the heap does not require unsafe. There is a shortcut doing this by using box ping. For pinging data where T is not unping, you have to maintain the invariant that its memory will not get invalidated or repurposed from the moment it gets pinged until the drop is called. This is an important part of the ping contract. So you can still shoot yourself, but now with the type, at least for the library developers and people who don't have skill issues, they can tell you, hey, don't do that. It's bad for you. Yeah, I mean that kind of makes sense, right? Because it's impossible to do Like unless you're not going like Turing complete, it's like just impossible to do that. Why is this not showing up? The string trait. The string trait is similar to future, but but can yield multiple values before completing, similar to the iterator trait from the standard library. Okay, have a string. Interesting. Oh, fuck. I think I've been. I think we will. I think the most important one is this one, right? But let's just finish streams today, and we'll see when we will be happy to read the next chapter. The stream trait is similar to future, but can yield multiple values before completing, similar to the iterator traits from the standard library. Yes. Attempt to resolve the next item. The stream is going to hold returns poll pending if not ready. It's ready. Return poll now if its string has completed. Oh, interesting. Yeah. One common example of a stream is the receiver from the channel type from the future crate. That's a good question. That is in fact a very good question. That is in fact a super fucking good question. That is in fact a super good question. All right. Alright, one common example of stream is a receiver from a channel type from the future crate. It will yield some value every time a value is sent from the sender, and it will yield none once the sender has been dropped and all pending messages have been received. Okay. Alright. That makes sense. That makes perfect sense, actually. Iteration and concurrency. Similar to synchronous iterators, there are many different ways to iterate over and purpose. Sorry. So there are many different ways to iterate over and processes the values in a stream. There are combinator style methods such as map, filter, and fold, and their early exit on error cousin trimap, trifold. Okay, unfortunately, for loops are not usable with streams, but for fuck. Unfortunately, for loops are not suitable for streams, but for imperative style code, while let and next try next function can be used. Alright, we have some with next. We get a string. It's a pain, and it's a dynamic string. If item is type So wait, is that generic in Rust? Well, I'm so stupid. I'm actually just don't know shit about Rust. Returns 932. Goddamn. Use this. Okay, for next. Gonna get mute. It's gonna get next, and the await. It's gonna get some, and then return some. Okay, it's literally just an iterator, isn't it? It's just iterator with await. Try next. Okay, interesting. However, if we just process one element at a time, we are potentially leaving behind opportunities for concurrency, which is, after all, why we are trying to write asynchronous code in the first place. To proceed multiple items for a stream concurrently, use for each concurrently and try for each concurrently. That's I get it. I think I've got this. I think I got this. Well, yeah, I think how long is this video? It's been almost an hour. It's not as long as the other videos, but I think it's already fairly long. And I think, yeah, that's pretty much all for today's video, I think. So yeah, one thing that I noticed with a lot of Rust learning content is that they're fucking long. They're like 3 hours of just dog shit. It's not like those people are doing an exceptionally good job at explaining things. They have like really bad slides, and they don't even cover the things that actually matters. Like I like just glimpsed through like a 3-hour video about like async Rust. They didn't even talk about fucking painting. Are you fucking kidding me? They literally spent like 3 hours just talking about this. That's it. 3 hours covering 2 chapters. I mean, to be fair, I'm not like, this channel is not like, you know, claiming to be a educational channel. But I think I went through those things faster. No, I actually don't think I was faster. But I can definitely see how I could went through those much faster than 3 fucking hours, because I mean, I was learning, right? I was learning and also like yipping half of the time. So like, and I'm also convinced that no, I only took like 2 hours and 30 minutes. So I'm still below the 3-hour mark. It is absolutely insane. Like you can literally just read through the entire fucking content with like a shit tons of commentary and still still get yourself below the 3-hour mark. I do not understand why those fucking YouTubers are wasting so much time on things that absolutely doesn't do dog shit. And like, I don't know, I think that's pretty cringe. But what can I say about it? I'm also a YouTuber now, so suck it up. There are many things that they should write, but they didn't write. Anyway, that's all for today's video. If you enjoy it, like and subscribe. Even though this series has a exceptionally good track record of having precisely zero view. Yes. Speaking of views, I don't know like why my Y2K videos getting so many like random ass comments. And those comments are definitely like, it's not even AI generated. It's just like random comments that's like probably generated with like a dictionary. It is really weird. But I guess that's all for today's video. I'm actually really weirded out by the... Oh shit. I was actually just like weirded out by... Actually, I think I just show it. I actually just got weirded out by this. Like, it's not even like they're spams, right? It's not even like they're spams. They're just like, it's not even like one of those like porn, like OnlyFans thing that people do. I'm just confused. I'm just confused, okay? But yeah, I think, I hope we both learned something, even though I'm pretty sure no one's watching this, but I feel very happy recording this. And that's all for today's video. Bye now.